In the world of energy storage, numbers matter. Charging time, energy density, cost per kilowatt hour, and most importantly, cycle life. So, when Donut Lab quietly surfaced with a claim that instantly set the internet on fire, a battery capable of 100,000 charge cycles, engineers stopped scrolling, investors leaned forward, and competitors went silent, because if true, this isn't just an improvement, it's a paradigm shift. To put that number into perspective, typical lithium-ion batteries last 1,000 to 2,000 cycles. Tesla's best LFP packs may reach 4,000 to 6,000 cycles. Even the most optimistic solid-state roadmaps aim for 10,000 cycles, but 100,000. That's not evolution. That's rewriting the rules of physics, or at least claiming to. So today, we're doing what headlines don't. No hype, no blind skepticism, no viral THUMB and ALS. Just the truth. What exactly did Donut Lab claim? Is it technically possible? What definitions are they using? And could this actually change EVs, grid storage, and robotics forever? Let's break it down. Who is Donut Lab, really? Before we judge the claim, we need to understand the company. Donut Lab isn't a traditional battery giant like CATL, LG Energy Solution, or Panasonic. They didn't grow out of automotive supply chains. They didn't inherit decades of lithium-ion infrastructure. Instead, Donut Lab positions itself as a deep tech materials and architecture startup, working at the intersection of solid-state chemistry, modular energy systems, high durability applications. Their branding is subtle, no flashy Ellen-style promises, no mass-market release dates, which makes the 100,000 cycle claim even more intriguing, because startups that lie loudly usually shout louder. Donut Lab didn't. They published technical hints, they spoke in academic language, and they let others amplify the number. That alone deserves investigation, not dismissal. What does 100,000 cycles actually mean? Here's the first critical reality check. A cycle does not always mean the same thing in battery science. A cycle can be 100% charge gives 0% discharge, 80% gives 20%, partial cycling, microcycles used in lab testing, or shallow buffer cycling in stationary systems. So, the first question is not, is 100,000 possible? It's 100,000 cycles under what conditions? Because there's a massive difference between 100,000 full depth of discharge cycles and 100,000 10% depth microcycles. And Donut Lab, like most serious labs, is careful with language. They purportedly reference controlled temperature environments, optimized current density, solid-state electrolyte stability, minimal volumetric expansion. This doesn't mean deception, it means context. And context is where truth lives. WHY solid-state batteries fail, PODAY. To understand whether Donut Lab's claim is plausible, we need to understand why most solid-state batteries fail. Solid-state batteries promise higher energy density, no liquid electrolyte, fires faster, charging longer lifespan, but reality has been brutal. The three main killers of solid-state batteries: 1. Interface degradation. Solid electrolytes crack at the boundary between cathode and anode. 2. Dendrite formation even without liquid electrolyte. Lithium dendrites can still pierce solid layers. 3. Mechanical screws. Charging and discharging causes expansion. Solids hates expansion. Most solid-state cells fail not because of chemistry, but because materials move when electrons move. If Donut Lab solved this, they didn't just tweak chemistry. They re-engineered mechanical behavior at the atomic level. The Donut architecture, TX or Weather. Most interesting detail is not the chemistry, it's the structure. Insiders suggest Donut Lab doesn't rely on traditional stacked or prismatic cells. Instead, they allegedly use a radially symmetric architecture, hence the name Donut. Why does this matter? Because radial symmetry distributes stress evenly, eliminates sharp expansion edges, reduces localized dendrite pressure, allows thermal balance. In simple terms, most batteries expand like a square box. Donut Lab's concept expands like a ring. That alone could increase lifespan by an order of magnitude. Not 100,000 cycles yet, but suddenly 20,000 doesn't sound insane. Material science, the real STR. Forget marketing. Batteries live or die by materials. Donut Lab reportedly focuses on sulfide-based solid electrolyte, ceramic polymer, hybrid layers, ultra-stable cathode coatings, low-strain anode alternatives. Is important. Most failures occur at interfaces, not in the bulk material. If Donut Lab engineered an electrolyte depth, self-heals, microfractures, maintains ionic conductivity under stress, suppresses dendrites passively, then cycle life skyrockets. Not magically, but mechanically. LAB conditions vs real WRLD. Now, let's address the elephant in the room. Lab results are not reality. 100,000 cycles in a lab could mean perfect temperature, perfect charging protocol, no vibration, no contamination, no manufacturing defects. The real world. Cars shake, heat fluctuates fast, charging stresses, cells manufacturing tolerances vary. So is Donut Lab lying? Not necessarily. They may be stating, Under optimal conditions, this cell architecture shows no catastrophic degradation after 100,000 cycles. That's still groundbreaking, but it's not the same as your battery will last 100,000 full charges. And that distinction matters. Where this battery actually makes SES the twist most YouTube videos miss. This battery is not primarily for cars, at least not yet, where 100,000 cycles actually matter. 1. Grid storage daily cycling. For decades, long-term infrastructure value, minimal energy density concerns. 2. Robotics and industrial automation, constant charge, discharge, predictable environments, massive ROI from longevity. 3. Aerospace and defense safety. Energy density, extreme reliability requirements in these fields. Even 20,000 cycles changes everything. 100,000 becomes revolutionary. Why automotive companies are watching tell why Tesla didn't tweet. Toyota didn't deny. CATL didn't comment. That silence is telling. Because big companies don't respond to fantasies. They respond to credible threats of donut labs. Architecture scales. It doesn't replace lithium-ion overnight. It outlives it. Imagine an EV battery that lasts the entire vehicle lifetime, requires zero replacement, enables million-mile warranties that changes depreciation models, insurance pricing, second-hand markets. That's why this matters. Manufacturing. The real precise layer deposition interfaces, cost-effective sintering, high-yield scaling. If Donut Lab can't manufacture at scale, 100,000 cycles remain a paper victory. But there's a clue. Donut Lab focuses heavily on modular units, not massive packs. That suggests controlled quality, easier scaling, lower initial CapEx. Smart strategies. Is the claim true or not? Here's the honest answer. Yes and no. Yes, it is scientifically plausible. Yes. Early lab results could show minimal degradation. Yes. Architecture plus materials matter more than chemistry. No. This does not mean instant EV revolution. No. Consumers shouldn't expect this tomorrow. No. It doesn't violate physics. This is not hype. It's early truth, and early truth always sounds unbelievable. The bigger C2 Arado Lab isn't claiming immortality. They're pointing toward a future where batteries are structural, durably, predictable, infrastructure grade, and the future doesn't arrive with fireworks. It arrives quietly, just like this claim did. Why this story? MATTS. Most battery breakthroughs fail. But the ones that succeed, they don't scream, they whisper, and let time prove them right. Donut Labs. 100,000 cycle claim may not be the final truth, but it might be the first honest glimpse of what comes next, and that makes it worth paying attention to.